This is section 9.4 in geometry. Today we are learning about arc measures. These are some new words, so let's get some definitions. An arc is a piece of the circumference of a circle. So it's kind of that curved line on the outside of a circle. Could be little, like this, could go way further, like that. The measures of the arcs of a circle always add up to 360 degrees. That's how many degrees there are in a full circle. Uh-oh, siren's going by. A minor arc is what we call something that is less than 180 degrees, and a major arc is something that is more than 180 degrees. Finally, a semicircle. The measure of a semicircle is equal to 180 degrees. That makes sense. Semicircle means a half circle. For notation, we got to be careful about how we name these because otherwise it might not be clear what curve we're talking about. The minor arc associated with ACB, we call ACB, and we put a little curved line on top of it. Pretty easy, right? We started with A, C, B, and so we know we're talking about this little edge here. On the other hand, the major arc associated with ACB, so if we want to talk about this blue part out here, we have to make sure that we're clear that we're not talking about the red piece. We're talking about the other curved line that connects those points. The way we name that is by saying, hey, we also want to include this point that's out here that's called D. So we will call it ADB and put our little curve on top of it. Finally, the semicircle associated with ACB. Actually, I think this shouldn't have a C in there. That's my bad. That should just be arc AB. You can see that matches up with what's in the diagram here. Then finally, the semicircle associated with angle ACB. So talking about this angle here, the semicircle is 180 degrees. So that's the part that's going from here to here. And so we're going to call that AD and put the little curve on there. And then we're just talking about half the circle. The main fact you need to remember is this 360 degrees. We're going to use that to set up a lot of our problems. For example, down here, find the measure of each arc of circle P where RT is the diameter. First, we should figure out RS. So R is here, S is out here. So we must be talking about this piece of the circle here, and it's already labeled in the picture. This one is 110 degrees. For the next one, we want RTS. This arc is going all the way around this way. Remember, if it contains this T, we got to cross through him too. So going all the way around this way. We're going to have to do a little bit of subtraction here. We know the whole circle is going to be 360 degrees, but then we're not including this piece here. So we're going to do 360 minus 110 degrees. So RTS must be 250 degrees. Then finally, the last one is asking about RST, going from R through S here, all the way around to T. We know from the problem that RT is the diameter. It's going all the way across the center of the circle. This makes it a semicircle. So from R to S to T has to be 180 degrees, or half of 360. If you feel good about these, feel free to try the practice problems on your own. On the back, it's going to involve a little bit of algebra. I'll finish up these two examples here in case you want to see those as well. Number 2, find the measure of each arc. For arc GE, we have G here and E here. So we're talking about this piece on the outside. There's a piece in there that's 40 and there's a piece in there that's 80. So we're going to add them together to get 120 degrees for that arc. Next, we've got arc GEF. So G is right here. We're going over here to E, and then we're going all the way around to F. So that's all three of those together. So 40 plus 80 plus 110 would give us 230 degrees. And then finally, for the last one, we're going the other way, from G around this way to F. This is pretty much everything in the circle except what we added up over here. So we're going to do 360 degrees because that's the whole circle. Subtract these guys here, 230. So our answer is 130 degrees for GF. This last one, we're going to need to do a little bit of algebra. This is going to remind you a little bit of what we did back in our angles unit in the fall. The piece over here is x. The piece over here is also x. This was what we called the vertical angle theorem, that if you've got lines that intersect like that, this piece has to be the same as this piece. We also know then that this piece here has to be the same as this piece here, or this angle here. So we also know that from A to N is 4x degrees. Then we want to figure out what x actually stands for. You could do it a couple ways. I like to use the fact that it's all going to add to 360 degrees because there are 360 degrees in a whole circle. So we can add all of these measures up and make it equal to 360. So 4x plus 4x plus another x is equal to 360. We can combine our like terms on the left. So we have 4 plus 1 plus 4 plus 1x. So that gets us 10x, and that's equal to 360. To solve for x, we then need to divide by 10 on both sides. And our final answer is that x is equal to 36 degrees. Make sure you get these examples filled in, and then try the practice problems on the back. Make sure you also check your answers on an answer key afterwards.